Hi, Mr. Williams.
Hello. Hello, guys. I apologize for the wait. Um, there seemed to be a little bit of logistics. I had some timings mixed up. All right. Let's fix this there. Okay. All right. You guys can hear me all right?
Yes, sir. Loud and clear.
Okay. Great. 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 All right. So I hear the two of you were there waiting on each other. Okay, so today we want to cover um rendering with Twinmotion, which that segment of showing you rendering with Twinmotion is going to be really short because I mean Twinmotion is super easy. But I also want to use the time to just um update you guys on exactly what is rendering. Um, that term has changed so much over the last year or two. You know, we have different software and different things that are coming out. So I wanted us to start from there. All right. Does everybody here have Twinmotion?
Not yet,
No.
but get in there.
Get in there. All right. Now, usually, when I do these sessions, I always start from the beginning, which is looking at exactly what is rendering, just to make sure you guys understand the core of what you're doing, right? So I have a presentation here I'm going to show you, and then we're going to dive into Twinmotion. I have I have a sample project here from a past student that I'll use as a sample. All right, guys. Hopefully, I guess well this will be recording, so you know I can you will have this to watch. But I tell you the truth, using Twinmotion is it is so relatively easy that I don't think you'll need a video. At most, all you need is a kind of an introduction, understand what it is, how it works, how to run it, and I mean everything else is straightforward. All right, so let me open this presentation here. All right. All right, let's see. No, it's not this one. It is another one. What is rendering 2020 version? Oh, Lord, where did I save it? I had it just a while ago. All right, so you guys are just about wrapping up 3D modeling. Okay, here it is. All right, let me just swap my screens around. Yep. And then I will just share this real quick. Oh, this one now. I can just share let's share the application. Yeah. Okay, you guys can see it, okay?
Yes, sir.
Okay. Okay, so let me start with asking you guys, what do you guys think rendering is?
It's adding color, adding backgrounds, or background entourage to a drawing to make it more believable and appealing, I guess.
Yeah, it's a good term. But you know, even if we're starting from the general definition, um, we do have, for example, rendering on a wall, meaning you're rendering concrete. So there's that term. So when we say rendering, we're definitely talking about in the visual art industry, right? So just so we can start there. I remember asking somebody what it is, and of course, if you ask a contractor what it is, it's different for them. So as it relates to this industry, formulating, adding color, shading, texture. I mean, pretty much we can attribute that to what we do in perhaps first year, thereabout. Anybody remember doing this kind of stuff?
Not the texture, sir, but the color and shade.
Yes, sir. Right, so this technically is rendering. It's just that it's not using, well, processing power. Actually, it is using processing power. It is using your brain, and you know your brain have to control your hands and all of that stuff, right? In your opinion, do you think this is easier, or do you think using a computer is easier?
I think using my hand is easier.
Okay,
So I feel like it depends on the strength.
that's a good answer. But
I
any
think
which way you take it, it does use some amount of nugget. You get me? Either you're going to have an idea how the brush strokes work and all of that stuff, or you have an idea what programs to use, what buttons to press, what hardware to have. I mean, you still need hardware when you're doing hand renderings. You need a pencil, or you need all the, you know, Prismacolor markers and all these things. You follow? But at the end of the day, what rendering have is time. So I would argue that to do a drawing like this maybe takes 10 hours. Granted, some of you might be better, so maybe it might take you 3 hours. You follow what I'm saying? Some of you might use different materials, maybe paint or whatever, so it might take you even longer, maybe a day. But one thing we can agree on is that the process of rendering takes time. And at the end of the day, time is what is common, no matter what method of rendering you're using. We can agree on that?
Yep.
Yes, sir.
Okay, so if we look at computer rendering then, well, it's pretty much the same thing. However, we use we calculate images, animations, simulations via the use of computing power, right? And who can tell me what that computing power is? What would you describe as computing power?
processor.
Okay, processor. But then why wouldn't this definition have the word processor there? What does that tell you?
There's more to it, or maybe processor isn't necessarily the answer.
Or isn't the only source of computing power? So I think computing power is a nice general term that we can use, because you do need to have, you know, hard drive space. You do need to have mouse, keyboard. I mean, you do need to have a video card in some cases. So you have all this other technology that you need to have. So at the end of the day, this type of rendering uses that. Now, when we're rendering on the computer, typically it would take something like this. You know, there's an image that is being processed, and it is being processed by the CPU. At least that is how we view it. Can we relate to this kind of thing?
Yes, sir.
But what I want to do here, and this will differ from the guys who did this course last year, because when we I think this year kind of marks the year of a new type of rendering. I mean, Lumion has been around for a while, but pretty much when you think about rendering, we only usually consider two types. We say, okay, either we're rendering by hand or we're rendering using the computer. And pretty much Lumion was kind of a new kid on the block. But that has kind of changed things around. Look at this render time. So to get an image like this using a CPU, it perhaps takes about 4 hours. So one could argue that computer rendering takes a shorter time than hand rendering. Could we say that?
Yes,
Yes,
sir.
we could.
Well, but what if you have to render this image 4 times? Because every time you render it, it has an error. You forgot to turn on a layer or something.
That depends on the resolution.
Well, there's that as well. So one could maybe argue that, okay, rendering on the computer can take a longer time because you're going to render multiple times. Another would argue that rendering by hand can be detrimental because you might mess up the paper and then you have to start over. To each his own. So anyway, so generally for the process of rendering, basically you put in some values and there is some kind of computing power. That same thing that replaces our brain in the case of hand drawing, that calculates these things. So if you look at this image I'm showing you here, if we kind of zoom into here, you can see we put in a couple of values. So we put in the time of day, the sun brightness, the reflection amount, the material type, the color of the material and that kind of thing. And then there is a computer that processes everything, and then like magic, with those metrics, we should get an end result like this, right? So at the end of the day, this in the center here is the real core of this. This rendering process is based on computing power. And this is where the two types of rendering start to differ, right? Now, there are two of these that exist now. I would say last year when I did this presentation, I would say there was only really one type. There were other types, but it just wasn't as popular. And what happened is that most people didn't use it as much. But everybody knows about Lumion that's in this class, right? Right, guys?
Yes, sir.
Right. And some of us probably knew about Twinmotion, but last year, it could maybe be said that only half of us knew about Twinmotion or Lumion. Some of us didn't even know about Twinmotion. And the year before is even less. So essentially what has happened to the world of computer rendering is that there is now two different types of rendering. There's what you call real-time rendering, and there's what you call offline rendering. All right. Now, this might be news to some of us because what happened is that there was only usually one main type of rendering. You understand? And that was offline. Now, what you notice here, offline rendering uses what you call the CPU, and real-time rendering uses what's called the GPU. So it used to be that, well, most computers that were developed, unless it's a gaming machine, but the average computer that you could buy for a decent economical price did not come with a GPU, or at least a decent GPU. Of course, a computer has to come with a CPU, or else it's just not a computer. So what happens is that most persons in architecture or in the visual industry always use what's called offline rendering. This is, for example, when you open Revit. Remember we did that last week and we rendered an image in Revit. The year before, you would have rendered in 3D Max. And some time ago, they used to render in ArchiCAD. But all of those types of rendering were offline rendering, which is really based on your CPU. And this is why, you know, it's important to have a good CPU in your system. But this year is the rise of the GPU, right? And I'm going to go into this in a bit. So in general, there are now 3 types of rendering in this visual industry that you guys need to know about. So there is hand rendering, which you knew about already. There is real-time rendering. That's the new kid on the block. And then there's offline computer rendering, which is the more traditional form of rendering. All right, you guys following me so far?
Yes, sir.
Now, now we already talked about the offline rendering already. This is what we have been used to over the years, when basically there is an image and the image needs to be rendered. Now, you might have a CPU in your computer, and that CPU kind of acts like the brain. It does a whole lot of stuff, and just like how your brain would know exactly how to color and know which parts of the image to shade in a lighter color and which parts to shade in a brighter color based on how light acts on a surface and all these stuff. This is what you used to use your brain to do, and the CPU is now what does that. Now, the general idea with offline rendering is that the more you have is the quicker it can be done. So for example, if you have one person acting as the CPU, then, you know, you have one hand that is drawing. But what if you had 8 acting as the CPU, right? I don't know if you remember, we did a presentation in DDM that first presentation where we talk about computer components and those kind of things. Anybody remember that presentation? No? Or was it so long ago?
Yes, sir.
Yes, sir.
All right, good. So the more processors you have is the more things you can do at once. So this is why traditionally we always used to try to get multi-core processors. I mean, this is why UTech, CSA spend thousands of dollars to get new computers in the lab that comes with an i7 processor, because they all now have 16 cores at their disposal. And the more processors you have, when you click render, is the more hands that you have drawing, or rather, the more computing power to calculate where light hits and where is reflective and blah, blah, blah. But what happens is that the industry is changing and there's a major shift. And as a matter of fact, there is a revolution that actually happened a couple of months ago that maybe only persons in the tech industry would see how revolutionary it is. Everybody know of the PlayStation 5, right?
Yes, sir.
Right. And we know about what's the Xbox version now? The Series X, that's what they call it?
XNS.
Right. So, you know, pretty much every couple of years, there's a new game system that comes out. But what happening now is that the realm of architecture and the realm of, let's call it, video games are in a collision course. As a matter of fact, a lot of things are in the collision course with video games, or just call it interactive entertainment, right? Because when we say video games, we kind of think of, you know, Mario and Call of Duty and these kind of things. But when you say interactive entertainment, you're talking about much more than that. Anybody here have ever been to Disney?
Yes, sir.
I mean, before COVID, you know, naturally, but
Yeah.
everybody ever been into one of those like interactive rides where, you know, 3D glasses and the rides are moving around and all kind of fancy technology that really tries to recreate a reality in front of your very eyes.
Like put and play.
Right. So it's in a way you can kind of draw relations to that, to like what's happening in the video game industry. Everybody probably know of virtual reality. You heard of that before, right? Nobody have heard of virtual reality
Yes, sir.
and augmented reality and these kind of things? And right now, those are big in the video game industry because naturally that's what makes money because people buy games. But they're using it in other ways. But the most lucrative way now is in the way of video games. But what's happening is that this kind of technology, other industries are realizing that, hey, wait a minute. If I can be walking down a corridor with a gun shooting aliens from space, why can't I be walking through a corridor showing my client what my design looks like? Everybody understand that analogy?
Yes, sir.
Yes, sir.
And this is the kind of thing that has been driving this new kind of take on technology. Now, the caveat is that, or what? Not the caveat. The catalyst that has happened is that every day some new technology come out. I mean, literally. I mean, can you keep up with? I mean, what the Note phones? No, is what you have now, like Note 20. Everybody hear about the Note 20, right?
Yes, sir.
Couldn't tell you.
Right, which is perhaps like, I don't know, like $150,000. And when you finally, if you manage to save up that money to buy that phone, by that time, the Note 22 will be out. You get what I'm saying?
Yes, sir.
So what's happening is that the technology is moving really fast and people are trending to different areas in technology. Now, what that means for us in the computer and rendering and our course is that there have been a kind of drift away from offline rendering to now what's called real-time rendering. And you might be saying, hold on, what's that on the screen? Is that ants? Why, you know, how does real-time rendering, or how does your GPU equal to, you know, ants? I mean, if you look at the kind of analogy with CPU, which is offline rendering, we can kind of compare it to the brain, right? So, you know, all those considerations that you had in your brain when you were trying to do this drawing, you know, which part is light and which part is shadow. The CPU kind of tries to replicate that with like formulas and algorithms and that kind of stuff. However, because of the industry, we're trending more to the use of GPUs, which is what we call real-time rendering. And the reason why there's ants here is that the GPU works a little different. And essentially what it does is, instead of having this massive brain that calculates and determines where shade and shadow is, what it has is some little tiny micro brains. Like, can you think of the size of the brain of an ant compared to the size of a human brain. Right? I mean, that's like huge, a huge difference. Right? You guys following?
Sure.
However, I don't know if anybody ever seen, on National Geographic how ants work. How worker ants work, how all of them kind of work together and they do these like amazing things. Well, the idea of the GPU is that rather than having this all-powerful brain, this processor, this i7 whatever processor or i9 or whatever the latest processor is, instead, how about having a combination of little tiny brains that work together? And that is the approach that GPU has taken. So what that has done for the industry is that it has what you call parallel processing, which CPUs are unable to do. So you might say, but okay, what difference does that make? Well, just to kind of put it in context, right? All of us have a computer, and chances are we have a, I don't know, maybe an i7. Because you're in architecture, chances are you have a computer that can hopefully do some stuff, can do some damage. Some of us has a gaming machine. Maybe the most expensive machine that you can buy perhaps has, I don't know, 8 cores. Anybody in this group have an 8-core computer? Anybody?
Yes, sir.
Yeah.
Yes, sir.
Okay, cool. Now, in comparison, the most expensive, perhaps reasonable price computer you can buy might have 8 cores or 12 cores. But the cheapest GPU that you can get will have over 2,000 cores. Over 1,000 cores. Do you follow me? So right away, you can see that with a GPU, it has massive, tiny kind of things. Now, what that changes for us in the industry is, do you remember that image that we were looking on earlier? Whenever the processor renders, this is the kind of thing that you're looking on, and it has, it's this big brain that tries to render this out. And even if it has multiple cores, the more cores you have is the faster this will render. Well, in real-time rendering, whereas this takes 4 hours to render this one frame, using the GPU will take approximately 1 millisecond to render this one frame. You guys follow me? So that is like faster than that you can blink your eye. And because of that kind of thing, what you find is that there are a slew of programs that are emerging that take advantage of this type of rendering, right? Remember, you used to wait 4 hours and now you wait 1 millisecond. Does anybody know what the catch is?
Yeah,
What's the catch?
cost more.
What?
It will cost more.
Not necessarily. Nope. Anybody else? What's the catch?
It takes more power.
Nope.
Does it have to do with the SSD?
No.
So it looks like it's only for rendering programs, not for like Revit and those things.
You have to
That-
subscribe for them. So it's an annual thing.
Not necessarily. As a matter of fact, Diane is more in line with the answer. You can repeat what you said?
So it looks like it's only for rendering programs, not for like Rivet and those things.
It
Hey,
only
that
focuses on the G. It don't use up the GPU. You won't really use much of anything else at the CPU, or probably a little.
okay. You're warm, but I get what you're trying to say. So to build on that point, um, your GPU cannot run Rivet. Or let me put it a different way. In our analogy, when we're talking about the whole thing with CPU and GPU, the GPU are referred to as like worker ants, right? I mean, ants are so tiny, you can squash them. They're just like so insignificant. If you have 1,000 of them, they're kind of significant. But even 1,000 ants still cannot lift this mouse that I have on the table. It's just impossible. They just don't have enough strength, energy, raw power in order to lift this mouse that I have. But if they're lifting little pebbles of, I don't know, sand and grass and whatever, they can lift that faster than 10 of us, chances are. 5,000 of them, chances are, can do that quicker. So what does that mean to us? That means that real-time rendering, it is very specific and it is very lightweight. And in the past, when you used to have Lumion and you used to compare Lumion to like an offline render, let's look at some examples of offline rendering. So for example, some offline renders that we have are, hold on, where's my slide? Where did it go? There it go. Right. So, you know, we have, anybody here use V-Ray and SketchUp? I think that's a popular one with students.
Yes, sir.
Yes, sir.
Right. And some of us use 3D Max. I don't think much of us use Maya. Most of us use Revit. Some of us has rendered with Revit. So these are offline applications. Offline applications, you click render and the CPU, the big hulky strong CPU, works out where all these light rays are to be bounced, and it takes a little while to do that, but it gets it done. Now, the trick is that the CPU can do way more things than just rendering. I mean, your CPU basically runs your computer. You know, from turning on the computer to doing anything, the CPU does it. The GPU can only do the specific task of rendering. So you can have a computer with a CPU and a GPU, but you can't have a computer without a CPU. You can have one with a GPU. Now, the other trick is that the CPU can do more heavy lifting. And I don't know, for those of you who are into rendering, you might say, in the past, well, some would argue even now, but rendering in Twinmotion just did not look as good as rendering with, I don't know, V-Ray and SketchUp. Does anybody have that point of view?
True. Preach.
Yes, yes.
But that now is a hot topic to debate, right? I mean, Lumion is getting better, right?
Yeah, that's true.
But offline rendering still has the upper end on quality. For example, everybody here has watched some kind of Disney movie. I don't know. What's a good Disney movie? I don't know.
Toy
Frozen?
Story.
Which
Toy
one?
Story.
Toy Story. No, Toy Story too old, man. Even though
Ice
that.
No,
Princess.
so you see Toy
Frozen,
Story 4?
Frozen.
Oh,
Have you
right.
Have you seen that?
Yes. Somebody
All
sent
right.
me a thing of that. So, right. Toy Story 4.
Oh, Big Hero 6.
I don't know if anybody has ever watched like one of those Japanese ones like Final Fantasy or Kingsglaive. Those are more like Eastern kind of stuff, animation. But at the end of the day, that compared to playing a game, the game graphics will never look as good as the Toy Story graphics. They look pretty good. I mean, when you look at Call of Duty and these fancy games, they look very realistic, but it just, I mean, if you put that against a Disney movie, you know, the Disney movie just has this other sense of refinement that it doesn't have. But the two of them looks amazingly realistic. Now, those two examples are what exists now in the architectural industry. You have more and more, you have what you call real-time render engines. And let me go back to that slide. Before it was just Twin Motion, I mean Lumion, but look how much you have now. Anybody ever heard of Unity?
Yes, sir.
Right, and we have Enscape. Anybody ever heard of Enscape?
Yes, sir.
Right, so what's happening now is that you have a rise of different software that is popping up using this type of technology. And though it doesn't look as realistic, even though that's an arguable point, as real-time graphics, it's very much believable. And especially for the realm of architecture, your clients will take a Lumion image or a Twinmotion image, most definitely. Right? So this is just what I want you guys to understand about rendering and where rendering is going, and that you know what you are using, right? You know how you're comparing them, and you know what drives them. So right now, we're going to use Twinmotion, and Twinmotion is what you call a real-time renderer, not an offline renderer. So hence you need to have a GPU, because the GPU
So I have a question.
promotes that. Yeah.
So say you're running Revit and you want to use Revit to render. Just to do the rendering part in Revit, can you set your GPU to take over and do that? Like, can you use the CPU and GPU at the same time and control when the GPU comes in and does its thing?
Well, put it this way. The short answer to that is no, is yes and no. Have you explained? Your CPU rendering, it's a good word to describe it would be brute force. How do you explain that? Let's say, for example, let's look at that image that we had as an example here with the rendering of a drawing. Think about this image that we did, right? Now, when you're doing this image, think about you trying to sketch this image out. There are a couple things that you have to process in your brain, like, okay, is this end turning towards the light? Is it away from the light? This is a window here, so it should be reflective. You know, what should it reflect? Oh, there's a tree on the left, so it should reflect the tree. These are questions that you are asking yourself, and you are figuring them out while you are rendering them on the paper. Now, if we equate that to the CPU, that's exactly what the CPU does. The CPU kind of does this, like, it works kind of like the brain in a way. Now, how the GPU works now would be like, the GPU, how it thinks would be like, okay, everything that is a window will get blue. Everything that is a wall will get red. Everything that is angled 30 degrees and is a wall will get dark red. And then it just applies it in one go. Now, what does that mean? It kind of broad brushes everything. Not all windows would be blue. Some windows are like, it have more shadow. It's turned more to the left, so it's more like light blue. Not all walls will be the same red, because even though you have a wall at 90 degrees, the sun probably doesn't hit that as much, blah, 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 blah. But a GPU rendering kind of just broad brushes everything. And that's why it does it so quickly. What it does is make intelligent assumptions as to what the thing should look like, and does it in a fraction of a fraction of a fraction of a second. But it does it so intelligently that when you look at a Twinmotion image or a Lumion image and you look at a V-Ray for SketchUp image, you say, wow, that's darn close. That looks, you know, just as good. But there's something about the V-Ray for SketchUp that just looks a little different and you can't pinpoint it. That is exactly how they work. No, because, so in a way, GPU rendering is a little bit like cheating per se. It is just like saying, you know what, all windows should be blue, make it blue. Now, in Revit, for example, the program itself has to be built in a way to accept this broad brushing. I don't want to call it cheating, you know, but this broad brushing of what something should look like. And Revit just isn't built in that way. It's not programmed from the ground up in that way. So so if it's not programmed from the ground up, then you have to do it the traditional way, which is the long way. You know, you think about it. When you click render in Revit, you know, it thinks about, okay, this is water. Hold on, this part of the wave is leaning towards the building, so it would reflect that part. And, you know, it's thinking about everything sequentially and solving them one at a time. Whereas the GPU is it just kind of broad brushes it and just does one swoop. There is this interesting video that I saw a while back that I want to show you guys. And there's this program that used to come on a long time ago called Mythbusters. Anybody know that? It's like a long time program where they try to like use science to prove that things are real or not real. Anybody heard of that?
Yeah, I heard of it.
Right. So the guys, so NVIDIA is like one of the top companies that builds GPU. And everybody knows about Intel. That's one of the top companies that build CPU, right? So, you know, there are companies that build this type of technology. So they did an interesting video comparing how the CPU works from how the GPU works. And they did it in an extreme way and kind of in a funny way as well. And I saved that for you guys so I could show you. Let's see here. What I would have to do is, right, I would have to switch the screen. So let me just show you that video and that will hopefully answer this question. And then we can go into Twinmotion, which there isn't really much to teach because it's so simple, but I will guide you through doing it. But the important thing is that you understand the technology behind this thing so you can decide how to leverage it. Oh, there's one other example I want to show you after this one. I hope I can find it. Yes, I have it here. But let me show you this interesting, kind of funny video of explaining the difference between the two. Where do we go? We go to share and let me look for that video. Here we go. And I need to share computer sound, optimize for video clips. Okay.
All right, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other.
Everybody's hearing and everything?
Yes, sir.
Yes, sir.
Okay.
In 3, 2, 1. Let me speed it up. Ladies and
So you understand how a CPU or a GPU, sorry, how a CPU works, right? So what it's really doing is, you know, it's thinking about, you know, how to hit the spots, and it's working that out for every paint palette, right? The interesting thing about a CPU is that it can be repurposed to do other things. So in that case, the CPU is painting a smiley face there, but that CPU could also do something else. The GPU can only do what the GPU is meant to do, and that's the real drawback. check out the alternative now, using a CPU to, a GPU to paint a picture.
Gentlemen,
Leonardo 2.0.
when we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10,
9,
8, 7, 6, 5, 4, 3, 2, 1.
Okay, so you guys understand that, right?
So
So the paintball has like one powerful kind of a thing, but the GPU has tiny thousands of little paintballs. But at the end of the day, what you want is an image. So the 1,000 tiny paintballs can get you that image. But let's say, for example, you no longer wanted to use the paintball gun to paint a smiley face. Instead, you wanted to use it to run around and shoot people. Well, you could still do that because you can just repurpose the CPU to now run around and shoot people with the paintball. But the GPU is just built only custom to do this one thing. It can't do anything else but just spray paint this one picture. So that is just understanding a little bit of the technology behind it. Now, I want to end by showing you some other advantages. Well, let me say some other options in using real time, and the reason why real time is now the thing of 2020. I don't know what will happen to offline rendering, but technology is, there's always something that comes up. I'm sure the offline rendering persons will come up with some other new fancy technology afterwards. So let's go back to this here. Oh, I'm going to stop the screen share. Okay. So in closing, the reason why you want to be looking into like using Twinmotion and all these other ones that we saw is that, remember earlier in the presentation, we spoke of how video games and architecture is on this collision course. And I'm sure you probably have seen very fancy videos of people putting on VR and being able to tour the houses and stuff like that, right? So because real time is so instant, now persons are creating what you call applications that in architecture, you can see adjustments, changes to your design instantaneously. And that is only possible with real-time rendering, right? So what was once used to play Call of Duty shooting aliens is now used to professionally demonstrate your architectural design and design options. I'll give you one example of that here. I carried an example for this, which is somewhere on this big hard drive. Okay, here we go. Package demos. All right, let me load this up. Hopefully I don't have too much things running at once. Let's minimize that. And let me wait for this thing to start. Let me do a shared screen. You guys are still here? You're still alive?
Yes, sir.
All right. Let me show you this other thing now. Well, this screen I have is much more wider, so it's going to look kind of interesting. So let me share that application here. Optimize for video. Okay, good. You guys can see? So this is oh, wait a minute. I shouldn't show it on this screen. This screen is too wide. But anyway, it's okay. Let's see if it works nonetheless. There we go. Okay, so one would think that this looks like a game, but remember before we could only watch videos, which we could mainly do it with offline rendering. Real-time rendering not only allows us to do cinematics, so this is a cinematic here. Everybody's seeing it?
Sir.
So what is happening now is that my video card or my GPU is currently rendering this now, right? All of those, remember those little parallel paintball thingies that you saw in the example? All of them are working simultaneously. All maybe 3,000 little tiny ant scores are working to get this done. Remember the example of the little ants? The little ants can't even lift my mouse off the table, but they can come together to give you images like this. So this now would have taken maybe, I don't know, a couple of weeks. I used to do offline rendering as work. So I used to wait I used to use like about, I don't know, 15 computers, and it would take about 6 hours and a giant JPS bill at the end of the day to render something like this. But now this renders in 10 seconds. Right? But where the revolution is not in these graphics, but the ability to create this. So this whole application you're seeing is what is delivered to the client. So the client would come in here and click play as if they're playing a game. And here I am walking around. Hopefully this, because I'm doing screen. Is it frozen for you? Okay, it's back.
Appreciate your computer, sir.
Yeah. So here I am walking around. Right? I mean, if this is a Call of Duty game, then it's a really good looking Call of Duty game, right? But I'm actually now walking around in real time, and I can approach this here. I can change the color of the floors. Everybody seen that? In real time. Let me walk down here. I'm not killing zombies or monsters, but instead I am looking around this design here that I've done. Now imagine you have something like this, and instead of rendering a video, but you could just render a quote-unquote game, and you give this game to your lecturers. And you know, this is your lecturers going through your design now to see all of the little aspects of your design. Might be good or it might be bad, because you don't really want the lecturers walking around your design to spot out all the things that you can't hide with a tree, right? But think about it more on the side of clients. So this is where the future is heading. And you can say this is pretty believable. It is not V-Ray for SketchUp quality, but I mean, look at this. It's how more real than this could you get? I mean, you can get more real, but right? I don't know if you're seeing it as clear as I'm seeing it on my.
So is it playing audio at the same time?
Yes, it is. So, you know, the birds in the background.
So what's the name of this website again?
Well, this is the actual example of a work done by a firm. So imagine you have a firm that does 3D renderings, but what's happening now is that instead of they doing renderings and delivering as video, they're actually building little applications, you would almost want to call it a game, but it's not really a game because you're not like doing anything. But they would deliver this, which is an executable file, not an AVI or an MP4, but it is a game file that you double click and then this pops up. So it's not necessarily a website, it's a firm that does this kind of thing. And if you think about it for a minute. Think about a complex game like Call of Duty. I use that because it's popular. I mean, when you're in Call of Duty, there's all kind of things that has to be done. There's breeze blowing, there's bullets flying, there's all kinds of AI that needs to work. In a way, if you take a game creator and put them in an architectural office for them to build something like this, they're going to be bored out of their minds. Because think about the environment that the gaming creator is coming from. He's coming from an environment where he has to like have monsters and blood splatter and all kind of crazy stuff. And you put him in a world where all he has to do is put some birds chirping and change the color of the floors. I mean, come on. You get what I'm saying?
Yes, sir.
So this is why I say the two industries are on a collision course. I don't know if it will be good or it will be bad. I mean, you guys do 4 years of architecture, but to show your architecture, what you produce will not be as close as what a video game designer produces. But yet a video game designer has no architectural background, but they can do this kind of stuff, which is more engaging to the client. So, you know, that brings about an interesting conversation for the future of this industry. So I'm showing you this so that you guys are not left behind. To build this kind of complex things, you would need like Unity or Unreal Engine. And if you notice, those were some of the ones that I placed on the slides. Twinmotion can build similar things, which is what we'll do now, but it will pale in comparison to what you could do with like bigger real-time graphics. So I think this is where I leave you as it relates to presenting to you what real-time versus.
Sir, in the real-time renders, the frame rate goes down when it is in real time.
It's all dependent on the power of your GPU.
Okay.
That is the thing. So now when you go to buy a computer, I mean, you just have to buy a gaming computer and you're well set. But I mean, the power of your graphics card will determine that. Now, I have some information that the reason why I'm saying that there's going to be a major shift in the industry. There's a couple of things happening. The first thing, there's a pandemic. So everybody is like all virtual now, right? So that is one. Because everybody is virtual, what happens, more people are buying more technology. So for example, the lecturers are asking you guys that, you know, you need to give them some kind of digital version of your work. You know, some of you might have a computer that couldn't do that. So now you have to go and buy a computer, but multiply that by millions of people. So there are a lot of people out there, a lot of students out there, a lot of workers that are looking into new ways to do things virtually. So you have a lot of firms that are looking into doing real time. The attention, the spotlight is on real time now because of the pandemic. It's like a catalyst. Now, the other thing, and this is a little bit geeky or techie, so to speak, but I want you guys to be aware of it. So at least you can know what's happening out there in the industry. Right now, if you guys wanted to buy a computer that had, you know, the kind of graphics to do this kind of real-time thing like Twinmotion. So let's say you like this Twinmotion thing and you want to invest in it. You want to be able to do more real-time graphics. Then you might realize that you have to upgrade your computer. So you start to go online, Amazon and whatever. But what has happened as of November is that the two major companies that create this type of technology, these two companies have recently released new technology that they have released two new technologies, two new video cards. That are pretty much game changers. So let me explain. If you want, let's say you decided to upgrade your computer because you want to start using Twinmotion. So you go on Amazon and you say, okay, I need some new graphics, and you look for a graphics card and you say, oh crap, a graphics card costs $500, right? And then you say, you know what, I'm going to buy the most expensive graphics card now. So you buy a graphics card for, I don't know, $1,000 because you want the best, because you want when you're showing your Twinmotion stuff, it looks all nice. Well, what has happened as of November is that they came up with new technology. And what happened is that technology is two times as powerful as the previous technology and costs half the price. So what you have is technology to do real-time graphics has just gotten a major boost. That's like saying a new computer came out and the new computer is 2 times as fast and is half the cost. Usually you don't get that kind of package, if you know what I mean. If something is twice as fast, it's usually twice as expensive. You guys follow me?
I follow, sir, but I
Yes,
don't
sir.
get it
Right.
to get the profit,
So, right. So what's happened now is that the technology that you need to do this kind of real-time graphics has thus gotten 2 times, 3 times faster and costs half the price. So this is why now you have a lot of people now jumping into like real-time now because they're saying, whoa. But what happened is that you guys gonna have to make it breeze off because basically nobody can get anything to buy because everybody is buying. There's a pandemic. You can only buy online. People can only use computers. So there's like a strain on computer parts. So if you wanted to buy like this new part now to do this Twinmotion thing better, you literally, it's out of stock literally. So there is like this big rush now towards buying this stuff.
Mr. Williams,
can't. Yeah.
Mr. Williams, first of all, fabulous presentation. But you say it's a new technology. Is it just a part? It's just a part in a computer. It's a new video card.
It's a new GPU.
It's a new GPU.
Right.
And this is something that you can put into your regular computer?
Yes, you can put it into your computer, but it hasn't reached laptops yet because it's just November that this was discovered. So, what happened is that you have the biggest, well, the only manufacturer that creates video card in the world, meaning if you buy a video card, you're either getting it from NVIDIA or you're getting it from ATI. No other company exists in the world. So ATI, both of them discovered this new technology called ray tracing. You guys heard that already. And ATI used this new technology to put the video cards in their PlayStation 5 and their Xbox. So now the new game systems have this technology. Remember, it's the same technology that you use to do your Twinmotion and that kind of stuff. They just package it and put it in game consoles. So, instead of browsing an apartment, you're shooting aliens or whatever. So this is why what happened is that the new PlayStation and these kind of things that have come out, they are roughly about the same price as what the old ones were when they came out, but yet they are like way powerful. It's because of this new discovery of ray tracing why that is so. So, so that is the world of video games. But now, the other company, NVIDIA, they have taken that technology and repackaged it now to sell to the computer side now. So right now where you have this new kind of GPU that is out, that does this stuff better, and it is so in demand. Let me tell you how in demand it is. It released on November, I think it was 4th. And of course, they released the most expensive version first. So the most expensive version costs 700 US. Sorry, not the most expensive, but the middle. No, the most expensive one. The most expensive one costs $1,200 US. So that's like about almost 200,000. And if you had the one before, that costed you about $1,700. These are all crazy people that spend money on the latest technology. But when the new one came out, essentially nobody could get it to buy because it sold out in a matter of 5 seconds. But because of the pandemic, you can't go into a store and buy it. So you can only go on, Amazon or whatever. And in literally 5 seconds, millions of technology just got sold out. So you have, and then what happened now, because remember we spoke about the video game industries and collision course with architecture. The people who are buying this are not buying it to do Twinmotion, they're buying it to play games. But you guys in architecture needed to do your Twinmotion, so but you can't get it because the same people want it. So anyway, so that's some news for you.
Sir, before we go any further, what's the name of the technology, sir? Does it have a specific name?
It's called ray tracing. That is the name of the what you call it? The new thing, the new algorithm, the new architecture as it relates to computers. So this new ray tracing technology does stuff triple times faster, looks way better, and ends up costing less. And that technology they have placed in the new GPUs now. Those new GPUs for video game guys, they make video games look better. The blood splatter look more reflective and the cars look pretty and that kind of stuff. But for people in the production industry, like architecture and all of that, it lets that walkthrough that I showed you, it goes much faster, it looks better as well. So you have those two industries competing for the same technology. And this is why, you just can't get it to buy yet. But give it maybe January, maybe it will wear off and stuff.
Mr. Williams, AMD does those cards too?
Yes, and funny you said that. Remember, AMD did it first, but they did it with the PlayStation. So those are not video cards for you guys to use, but they, that technology is in the PlayStation and the Xbox being used to play games. One could say it's a business move because they can make money from that. NVIDIA now took that and did it for computers. And then now, this month, ATI released that now for computers. So it's the new thing. It's going to be available soon, but right now, because of the pandemic and because everybody wants computers to buy, it's just hard to get.
Mr. Williams, if we have AMD processors in computers, well, we can't we can't just dig it out of the PlayStation and
Mr. Williams.
Yeah.
They tried it earlier, late last year with the RTX card.
Exactly.
Which AMD came out with it first and then Intel copied a version of it.
Who knows? Whichever one. The two of them are in competition.
Yeah.
But yes, it's the RTX card and it is available now. But the ones that are available now are the more expensive ones with less performance.
Yeah, it still has some bugs in it too.
Yeah, man.
The new laptops, ADM laptops with it, it's still working out the little kinks.
Right. But to be fair, we are talking about Benz, BMWs, and Jaguars. We're not talking about Corollas and Hondas. So I'm just saying, in everything that we're discussing, you're talking about top of the line stuff. You know, it's. But I'm just kind of putting this in context for you guys in this presentation to let you know why you would use real time, where Twinmotion is coming from, where Lumion is coming from. There are more programs that are using this kind of technology, and then the actual technology itself has improved, and there's a big rush for it. So, you know, in 2021, I wouldn't be surprised that, you know, everybody is doing more real-time stuff, whether it's playing video games or doing architecture. You know, it's like the same thing nowadays, which is really interesting. So with that,
Mr. Williams, me again.
Mm-hmm.
The term ray tracing is an old graphics term, though, eh?
Yes, it is. It has been around for a while, but essentially, in a nutshell, ray tracing was usually only possible with the processor. Think of it as what you guys did in first year architecture when you had to project a shadow, and you had to sit down with your paper in front of you and project, you know, draw a line that traces where the shadows are so that this sketch that you're doing or inking would look better. So it's the same thing that the CPU used to do, you know, but it takes a while, which is what you saw. So what happened now is that the real-time world, remember, that's the world where everything renders in a nanosecond. They have figured out how to get that, but in real time, using all kinds of algorithms. So what your CPU used to do and work out, trace where shadows and lighting go, now your GPU can do that in real time. So that further is a catalyst to why a lot of people want this now, because not only will their renderings look good, but their video games will look good. And it does it in real time. So so that is where the term ray tracing has come from. And that is the technology, the new technology that they have managed to implement in GPU rendering and let it be cheaper. That's just the crazy thing. It's like, that's just the crazy thing. So
is it possible, Mr. Williams, that the shadows are not as detailed?
Well, you can't really look at it as simple as that, because there's all kinds of like really intricate things that bring it up. But right now, if you like look at an example video that says, okay, this is one with ray tracing and this is one without, you know, it's like you might say, okay, one looks a little nicer in some cases, one looks very nice in some cases. And you might say, you know, what's the real point? But the real thing is that, remember, is the technology makes real time more attractive to designers. So it's not that ray tracing is a make or break for you. It's not like it, you know, you need to stop using SketchUp and V-Ray and start using Twinmotion because of ray tracing. It's not directly that. It is just that it has made it more popular, and it has made faster technologies cheaper and better. So it's like you're saying, it is just more of a pull towards why you would use Twinmotion and use Lumion and use what's the other one, Unity, and all of these things. And on top of that, now, remember what I just showed you is that people are now delivering games to clients. I mean, if you were competing in a firm where one firm was giving a video of an apartment and the other firm gave a walkthrough where the client can go through and change the color of the floors, who you think would win that contract? You follow what I'm saying? So there is this is why it's becoming so popular now, because at the end of the day, what sells more and wins you the contract is what is more appealing to the client. and you can produce it quicker using less electricity with cheaper technology, that looks good. It's like, so that is what is happening in the industry today. And that is why we're using Twinmotion now and Lumion in architecture, in the architecture school. That's why it's a part of the CSA's list of programs that we use. That's where the industry is trending. Okay.
Yes, sir.
So what I will do now, I'm going to open the.
Oh, you said Friday at the meeting.
I'm going to open the files now so that we can do the work in Twinmotion. And there's, as I say, there's literally no little work to do. Twinmotion is very straightforward. They have a lot of resources available. So pretty much I'm just kind of guiding you towards it. So I'm gonna share my screen. Let's share.
Sure.
Yeah.
I wasn't here for the first part of the presentation, so I wasn't sure if you had mentioned it. There's a reason why you're gravitating more toward Twinmotion.
No, remember, somebody did come up there with the report and the title. Remember,
Mute Jamar.
Yeah, mute Jamar. Right. Right. So, well, I kind of covered it a little bit in my explanation, but generally, there are a couple of things that is propelling it. First thing, there's a pandemic. So hence people are working more virtually. The next thing is that we looked at offline versus real-time rendering. Real-time rendering is instant. You can make changes on the fly, things like that. So because it's more instant and because we're driven more towards using virtual, the two are like catalyzing each other. Then the other thing is that there's new technology being released now, making real time even quicker and more affordable. So all of this combined together would let the artist, whether you're an architect or a general artist or whatever, start to look into real time more. So in CSA, we used to use offline renderers. We used to use 3D Max to render. But because the industry is trending more to real time, we have actually switched in the course to using Lumion. It is quicker. It doesn't allow the artist to. It doesn't expose the artist to all the options. For example, that example that I showed you with the real-time apartment, you can build that with Twinmotion or Lumion or Enscape. You know, you would need to use now more complex programs like Unity and Unreal Engine and CryEngine and these things to build it. And you've gone into the realm of game creators. But just in the realm of Twinmotion, you're able to do things instantly. And that's why we use it. That's why we have switched to using it. And it's free. Twinmotion is free. Lumion is not, by the way. Well, free to students. All right. So those are the reasons why we end up using that.
All right.
Okay. All right, so what we are going to do now is I am going to share, which screen am I going to share now? I'm going to share this screen. Okay, so we're going to open Revit. There we go. You guys can see the screen okay?
Yes, sir.
And then we're going to open Twinmotion.
Sir, question. Having that running in your background, doesn't that take up?
Oh, that is cool. Yes, that is an awesome program I found on Steam that has a interesting video background. By the way, this
It's not slow
background
down the computer.
No. I mean,
Really?
yes. It takes some amount of resources, but it's using it's using a combination of your video card. Remember the video card in that example that we showed that has thousands of little tiny ANS processors. So in the realm of the video card, what is used to run that background is nothing, because it's not using your CPU, it's using your GPU, and your GPU have thousands of little cores, right? So remember we spoke about that. We were saying that, so for example, this I'm running off of my laptop now. This is Twinmotion here running, and it's running fine, and the background is there, and I'm running what's this, Revit. Of course, Revit is not really using the CPU as much. It's not really using the GPU as much as using the CPU. But this is just to show you that this is why real time is so crazy, because you can get all of this stuff running. I mean, all of this stuff is running, and your CPU, your GPU usage is like 20%. But if you try to run this using your CPU, it wouldn't even run. So this is why video cards are becoming like hot bread. It's like, because it has all this technology packed in there that visually it's at no cost, but yet it can't run Word.
True.
Yes, you know, that's just weird, but that's what we want in the visual industry. We don't mind. We don't want to run Word. We want to run Twinmotion, right? Anyway, so that is pretty cool. So anyway, all right. So the first thing we need to do, guys. So I won't even try and compete with the thousands of YouTube videos out there in how to use Twinmotion. But the first thing you want to do is you want to go to the website. Close this. You want to go to the Unreal Engine website, or you can just type Twinmotion in Google and you carry you straight to Unreal Engine. There is Unreal Engine there. So Unreal Engine, sorry, Epic Games is the company that owns Unreal Engine, right? I mean, so think about it. A video game industry owns a software that architects and designers use. You see where we're going with this?
Yes, sir.
A couple years ago, we had Twinmotion. It was kind of the underdog. You know, everybody said, oh, Twinmotion is quick, but it don't look as good. And the company that owns not Twinmotion, Lumion, I keep getting them mixed up. So the company that owns Lumion, which is Lumion don't make games, they only make Lumion, right? And here is a company called Epic Games. And what Lumion is doing on a Saturday, they're doing in their beds on a Sunday afternoon, if you understand where I'm going, right? So, and this is why Epic Games came out with Twinmotion, and you can look at it. It's, you know, when they talk about things that disrupt an industry, Twinmotion, sorry, Lumion costs $3,000. Anybody ever look at the price of Lumion?
Yes, sir.
So Twinmotion is, well, it's not free anymore, but Twinmotion costs about $300 US. And Lumion costs about $3,500 US. So this is Lumion here. Lumion is for the architectural industry, which is kind of a premier industry. I mean, architecture is a kind of a elite kind of industry, right? Things are expensive, buildings are expensive, professionals are expensive. Unreal Engine is a part of the video game industry. I mean, you buy a video game for $50, you buy an app for $1. You get what I'm saying? It's two different industries. So Twinmotion you can get for free and for cheap, whereas Lumion is more priced within the industry as a professional architectural thing.
It's like an Apple Android thing.
Yeah, it's like an Apple and Android, but it's
Right,
a bit more.
Sir,
But it's yeah. Go ahead.
Which one would you say is better though, out of Twinmotion and Lumion? How can I question that?
That's a very
who's the head brother? You know the answer already.
Hold on, what's the answer?
But Lumion, I think Lumion have a more variation in the customization.
I would say Lumion. In terms of obviously,
the new Lumion. The new Lumion realistic feature and 3D mapping of inserting images. I think that puts it ahead of Twinmotion with that capability.
I mean, Twinmotion can do that also.
Yeah, but the realistic to catch back.
Yeah, that's a thing.
Catch back it is cleaner on the Lumion.
Also, displacement maps really.
Displacement map.
Displacement map.
City map is a bonus too.
Okay, I hear you. So, okay, so how I would compare that question is, let's say that if you were to say that you had a new car that came out, somebody invented a new car. What's a new car company?
Tesla.
Tesla is new. Okay. So let's say you have Tesla. Then you have another new company. You know, everybody know Lucid?
No.
Good, because they're new. So Lucid is an electric car company. They are fairly new. They've, you know, Tesla is also fairly new, but since we're talking about electric cars then, so think about comparing, think about comparing Tesla. Tesla come out with a new car, nice and fancy, but let's say, give me a big company now, Toyota. Let's say Toyota came out with an electric car. And, you know, two of them are like neck and neck, kind of like Twinmotion and Lumion. You know, one have AC, the other one have fancy this, one have a bigger touch screen. You know, they kind of go back and forth fighting, but they're pretty much within the same realm. Now, which one would you stake your claim on more? The electric car from Tesla or the electric car from Toyota? And tell me why.
Stake it on Toyota because Toyota market, or the people who they market to, are everyday people, right? Tesla is more high end. You know, when you think of Tesla, you're thinking of celebrities or influencer.
And that's why Tesla would be better.
No.
Because
it would be better in the sense that yes, the technology is better, but what can you afford?
We're not talking about affordability. We're just talking about how it is.
No, wait. Remember, the two cars
affordability
are neck and neck. Hold on, the two cars are neck and neck. In terms of features, have almost the same features. They just vary.
And I'd probably go
but
for
the Tesla costs more. The Tesla costs more. The Tesla is the Lumion, so the Tesla costs more, but the Toyota costs less.
My opinion, sir, is that
which one?
You always go the more established company because while they boast the same features, one is proven for a much longer time. So you wouldn't go to buy the new Toyota electric car because the first time around they're doing it, that's bound to have a lot of problems. Well, Tesla has been tested for years having electric cars. That is their thing. So if you're going out to your way to buy an electric car, you would buy a Tesla, not because of not just because it's more expensive or also, but because it's guaranteed to not have.
They have more experience.
Yes,
Good
sir.
point. Good point. Good point. Anybody else have different points? Another person say Toyota have a bigger market.
Toyota Land Cruiser.
Say again?
A Toyota Land Cruiser. Toyota got certain brands that are still proven throughout the years. So
overall, Toyota has the overarching experience generally with automotives, but Tesla is very specific to electric cars.
Technology, basically.
Okay.
Toyota is old school and new school. They implemented both. They have some electrical Toyota cars as well.
Well, that's an interesting battle. I don't think there's any wrong or right answer, by the way. So I'm not saying this because I know of the right answer or anything like that. It's a discussion, which is what academia is all about. So
yeah, but you can't compare with these examples. It won't be a good comparison.
Well, no, there are some things that are comparable. So for example, Twinmotion is new to a lot of us. In the architectural industry, Twinmotion is probably not even known. But Lumion is known, and they have been around for probably about 10 years, maybe, or 8 years. So it's a new thing in the architectural industry, but it is being more and more popular. You said Twinmotion to an architect out there. He said, what? What's Twinmotion? Oh, it's like Lumion. So look at that phrase. It is like Lumion. You get me? But there is something else to consider. So, Lumion, whereas it has been around for a while, but Lumion is essentially a game engine. So Lumion has used the game engine technology to create this product for architects. No,
Twinmotion, sorry, I mean Twinmotion.
Sorry, Lumion. No, Lumion has used a game engine to create a product for architects.
Okay.
You follow me?
Sir,
that is what Lumion has done. Now here is the caveat.
What do you think about Enscape?
No, hold on, no man. Enscape are small fries. We're talking about the two big dogs here, right? So that is Lumion. Now, Twinmotion is new, but think about Toyota. Who owns Twinmotion? Epic Games. Now, how long has Epic Games been using game engines?
A long time.
Perhaps. Well, I remember playing Unreal Tournament when I was in high school.
Oh, I know that game.
That is so old, right?
Yeah. About it said 29 years, sir.
Or even more. But essentially, Epic Games has been in games forever. Just like how Toyota has been in cars forever. So this is the trick. So Epic Games look over on the Lumion guys and say, but this brother not easy. He's coming to use my tools to build something. So they come and say, all right, I'm going to build one called Twinmotion. And for Epic Games to build Twinmotion, they're saying, well, for them, Twinmotion is a very boring game. If you think about it, Epic Games that have Fortnite and all these other games with spacecrafts and explosions and all that kind of stuff, they are building a program that has no explosions, no aliens, no guns, just environments. For them, building Twinmotion is a flick of the thumb. But they are new in the architectural industry. But they have been around forever in the gaming industry. So you get where I'm going? So in this case, Twinmotion is the underdog, but he's the child of the founding father. whereas Lumion is the established one, but he's a youngling in this game environment thing. So my projection is that Twinmotion is projected to overtake Lumion because they just have more growth overall. They don't have it yet, but they have it more overall. And it's cheaper. Don't forget that. If you leave school and you start a firm and you wanted to have 3D renderings in real time, would you buy Lumion for $3,500 per license? Per license. So you get 2 guys to work for you. 2 of them need that, you know. I mean, if you want to be legal. So on the other hand, Twinmotion now, 40,000 Jamaican dollars. Come on. Versus $500,000. Come on. So then that is what you have. So when you ask yourself that question, you have to look at all of those factors. Anyway, so I was just telling you how to get it. So there are 2 things you need to get. You need to download Twinmotion, which is about 5 gigs. And you also need to get what's called, you need the Revit to Twinmotion link. Right.
So it should be on the same page that you're on.
It is there now, but okay, it's got it. No, and it is somewhere down here. By the way, you guys should have this already because I can't go through all the steps now. I'm just
You're talking the plugin.
Right,
Yeah,
you need a plugin for Revit.
Oh.
Right, here it is. Download plugin.
Yeah.
Right. So you of course you don't need the plugin to run it because you can always export, but the plugin makes life a ton more easier. All right, so you're going to download the one for the Twinmotion you have. So I have Twinmotion 2019, so none of these will work for me. So I have to go to Twinmotion for Revit and go to archive versions. And then I would choose 2019 and download. All right. Now Revit has to be closed for you to run it. So just install it. And what that means is that when you start up Revit, and I've just opened the project file. So I'm going to open. Desktop files. I have it here. It's called sample project. Here we go.
Sorry, the screen is blurry. I don't know if it's from me alone.
No, it is because in Lumion, hear me Lumion, in Zoom, I've chosen the option to optimize for video. So let me turn that off. It will make it slower, but cleaner. Is it sharper now?
Yes,
Yes.
sir.
All right. But it's a bit more choppy.
Yeah.
Yeah, that's the thing. Okay, so I'm gonna pause this thingy here. All right. So this is what you should have. You should have something roughly like this, and up the top you should have something that says Twinmotion. And when you click it, you will see C in Twinmotion here. And I mean, literally, that's all you need to do to see your file there in Twinmotion. So I'm going to click that, and it's going to say existing project. Do you want it an existing project or a new project? I'm going to say new project. I have it in an existing project, but I'm going to go from scratch. Do you want to save? Yes. And we're going to save this to the desktop as sample project. I'm only going to focus on the things you need for the assignment, because there are like a ton of stuff that you can do, but let's only focus on that. All right, everybody seeing this here?
Yes, sir.
Sir, it read the Revit for me for the tree and register as something else in Twinmotion.
Exactly. So for example, this person that you're seeing here is this person that is here. So that is pretty cool. I mean, how easy can you get? Lumion has a similar link as well that interprets the models. So pretty much for me, both of them are on par, but I mean, legally, you can just download Twinmotion and we can have the class. Lumion now, we have license for UTech, but it's only for UTech machines, so you'd have to be in the lab. You understand? There is, for me, who uses 3D programs to an advanced level, Twinmotion has certain edges, but those edges that Twinmotion have and those edges that Lumion have, the trade blows every upgrade. So when Twinmotion come out, Twinmotion had VR, but that's only because they came out new. Lumion now has VR. And then you might have another one that says, okay, Twinmotion has objects. Then Lumion gets objects. You have another one now, Twinmotion had weather systems, and now Lumion has weather systems. So, I mean, the two of them are going to be neck and neck. So for me, it's not about which one has the newer feature. It's the broader picture. You know, which one costs more, which one costs less, which one has the longer, the longevity for connection to other applications, you know, and these things. Okay, so so in Twinmotion, there are, I'm just going to do this class in the form of advice, not using the program, because using the program is really simple and you can get a lot of that from YouTube and so forth. So I'm going to do some advice on this overall usage.
One question I had.
Yeah.
So you have your landscape that you import from Revit into this, right?
Right.
Which is what I'm seeing. So you want the surrounding area to kind of merge with that.
Yeah, that's what that is a focus on this exercise as well.
Okay.
Right. So keep in mind though that this file is linked to the Revit file. So what that means for you is that you can't, for example, this guy here, you can't delete him. If I hit delete now, he won't go. Right? And this you can't you can't move him. Same for these trees, you can't move them. They're there. And this is because they're here in Revit. So for example, if I should move this guy here over like that, and then I go to Twinmotion here and choose Scene Twinmotion, then he moves over like that. Oh, and then he regenerates as a different guy. So that's another factor. All right. So for example, yeah.
I don't think Lumion can do that, and I don't think Lumion recognizes Revit trees and people and vehicles. Some vehicles. I don't think Lumion recognizes them. Well, I have tried, but never. When I export it or live sync, it never go over. I'm not sure if I'm doing something wrong or if that's.
Yeah, but for me, that is still trading a blow, because one would say they would rather not work and have everything linked, because, you know, suppose you want to delete something, you know, another might say, yeah, but I can work on my design side by side like this, and this is beautiful. Then Lumion might have the next version and it supports it or not. You know, it's just a matter of two guys, an Autodesk guy sitting down with a Lumion guy, and the Lumion guy say, hey, if you give me this feature, I'll give you $1 on every license we sell. And, you know, it's just business negotiation that determines those features. You know?
Sir, so if you bring your project into Twinmotion, but it's like, you see how Twinmotion has a ground plane already. What if your project like it doesn't start at ground plane like you would like it to?
It doesn't necessarily matter. So for example, I could select this ground plane now and delete it. And you would just be kind of floating in this weird space. If your project was below the ground plane, you could just move this ground plane lower or higher and not have to move your actual ground plane here. So for example, this building, where is 0? I think 0 is here. So this is actually below. No, 0 is at the footing. So this project used the datum point at 0. Additionally, you can just move your datum point in Revit and it will adjust your entire project up and down. So for example, to move, if you want to move your entire project apart from selecting it and moving it, because that is really complex and that can cause issues, you would have to go to, you would have to view everything. And here is your datum point.
Symbol on Twinmotion to move the ground plane.
Say again?
How you get that symbol to move the ground plane up and down in Twinmotion?
Okay, this symbol will appear in the center of this large mass. This is just a really large mass. This is all that is in Twinmotion.
Oh, okay, yeah, I see.
Right. Actually, I'm so far away that I can't even see where the thing is. So by the way, okay, so just a little bit on the interface. On the left-hand side, where you see this little arrow, these are where all your, what do you call it now? Create options are. So if you want to create stuff, it's on the left. For stuff that already exists, it's on the right, right? So when you go to this little arrow on the right here, this little arrow here, you can actually get a listing of all your items. So for example, I'm so far away that I can't even see my building. So what I would want to do is I would want to go over here to this arrow and select like an object like the footing and just press F to zoom into the footing. So now I'm kind of back. I'm back here. Okay. So remember, the right side shows you existing stuff and the left side gives you new stuff. And the bottom gives you options to edit. These are where all your properties bar is. In my opinion, like I'm used to my properties bar being on the side, but you know, to each his own. And by the way, you can't really move this interface. That's one thing you have to remember. Programs like Twinmotion, Lumion, Enscape, those are not professional real-time rendering programs. And when I say professional, don't think that I'm dissing it. Meaning that you are not, the floodgates aren't open to all the options available to you. You have very controlled environments which you have to work within. So for example, you can't model a tree. You have to choose one from the categories and you can't change the interface. You have to work with what you have and things like that. But that's fine if that's what you want. Okay, so continuing, right? So you asked about the ground plane. You could either move the building or you could move a datum point. That's this datum point here. But this would shift your entire project. And I wouldn't move this. This would not really solve your problem because it would make your, it's still not going to change your levels. Your levels are referenced based on the position of this object. So if I move this up, all the levels and everything will move up to. But in Twinmotion, it might register as, actually, no, it won't register. It won't register. So that's just not an option. You just move your object up and down. Because this Twinmotion is reading this point as 0. And 0 compared to the building is like here where this is. Anyway, so moving on to the next point. We're talking about the landscape. That's perhaps the first thing that you want to do to enhance the landscape. And hold on, does Lumion has landscape sculpting? It does, right?
Yes, yes.
Yes, sir. Yes, yes,
Okay,
yes.
good, right. So Twinmotion has that as well. Twinmotion landscape sculpting is very similar to Unreal Engine's landscape sculpting, and Unreal Engine has been sculpting landscape from before I was born. So one could argue that Twinmotion, which is the daughter of Unreal, should have a better advice. But who knows? Who knows? So the first thing we want to do is I would actually hide objects that look weird. So for example, this object here, I would probably not even use it. I would probably just use an object from Twinmotion, maybe. So to get a landscape in Twinmotion, I would need to go here. I would need to go to vegetation and landscape, go to landscapes. And this is where it can just create a virtual landscape for you. You start off with a virtual landscape already. So this is like creating another one. So I'm going to choose this rocky grassland as a starting point, right? And you might say, but you only have 2 working with, but 2 is quite enough because you could modify the flat to make it look rocky, and you could modify the rocky to make it look flat. And you can change the grass in the flat. So technically it doesn't matter what you start from. All right? You guys with me so far?
With you, sir.
Okay, so let's do the magic. So I'm going to actually delete this ground here. Press delete. I'm going to click on this rocky terrain and, oh, I think you have to drag it in. There you go. Now, of course, things that you create in Twinmotion will not show in Revit, naturally. And you can't edit the building in Twinmotion. You can change the materials. Hold on, can you? Yes, you can. You can. Yes, you can. Okay, good. So now my terrain is created. So if I zoom out, that is my new terrain there. So what I would do first is, where's the center of this terrain? I don't even, oh, I would go to my move tool here. Oh, you can't actually, here. Why aren't you coming up? Okay, let me zoom in. Okay, good. So now that you have the landscape here, this is where you have your sculpting tools. Remember down the bottom here is where all your properties are. So actually, I'm going to use this sculpt tool here and let me zoom out a bit. For those of you who play first-person shooters, I'm using ASWD to move around. And just like when you play a first-person shooter, shift is to run. So shift is to like move faster in Twinmotion. Okay, so I'm going to change the diameter of this. I'm going to make it really big. I'm going to change the intensity to like 1% because that's pretty strong. And I can even change the shape of this. I'm going to leave it as a circle. I'm just going to bring this up a little bit like that. There we go. Bring this up a little bit. So I'm moving it in big chunks near to the building. There we go. Just get this little part on here just to reach there. Good. Then I'm going to decrease the diameter a bit now. Kind of go in here. And can I have 0.5? No, I can't. Okay. So I'm going to change this to big. And I'm going to just reduce the center of this a little bit. So I have a nice little patch of green, of grass there, of sand. And I'm going to decrease this little part a bit more. Let's make it a little smaller.
The water can grow this up. Water grow. Water can go there.
I mean, you can make like a pond right there. So like
Exactly.
that's
That's exactly what I would do. So
mosquito.
I'm actually, it doesn't matter based on your view. Remember, you know, what is needed in for your assignment is a 360 view and a view of the building. So it doesn't really matter what's happening on the outside. So let me go to raise. Let me put this to 5%. And I'm going to just raise this a little more around the building. There we go. Right. Good. Then for me now, if your base here is looking good, then I guess you can use it. But for me, this is looking horrible. So I'm going to go into objects here and I'm going to turn this off because I don't like it at all. Then before I put in the water, there are a couple ways you can add water. I think the easiest way is just to use the ocean water. But before I do that, I want to paint a little bit here. So I'm going to go to paint. Oops. Right. I'm going to go to paint. Then I'm going to choose a material like sand, maybe. When you choose it, just give it a little while to load. There we go. Let me close this. Paint. Did I not choose that? Oh, sorry. I didn't drag it down the bottom. I'm going to choose sand.
Drag it and add it to one of those. Yeah.
No, but okay, right. There we go. No.
Yeah.
You can just paint it on.
No, I'm gonna do it. I have to add it to one of them.
No, man. You can paint it on, man.
In paint right now.
In
Right.
paint, so you can try paint it.
Come on. Just let it load. Okay, good. There we go. There we go.
All right. Yeah.
So you can change the scale of this and the diameter, but I would kind of just paint a little bit there. You know. And then for this, well, I guess maybe this is okay, but this is the thing is you can't manipulate this text right here in Revit.
I wondering if you could change it in Revit and then you just use an overlay in Twinmotion.
Well, what you can do is try and neat up your versions in Revit, you know. So you can go into your landscape tool. I mean,
that's
landscape
stress,
tool, yes, it's stress. It's I really don't like the landscape
I had that
tool.
problem. Yeah, I had that problem.
Me too.
Yeah,
Like
and
a
that's the
very
thing,
sharp
because
edge that looked unnatural.
but the thing is, some people would just replace it altogether. I could. Okay, let me come out of this.
Or just put some rocks on top of it and hide it.
Ah, see, but
Real.
you guys already, you know the thing already, man, right?
Yeah.
You could also kind of sculpt this a little bit more. Let's go back a little bit, sculpt it a little bit more. To rise up, change the diameter a bit smaller. Just kind of rise this up a little bit more like that. Good. Then there are a couple ways you can do the water. You can put in, if you were doing a pool, for example, you would use a body of water, but because this is like an ocean, so you want to go back to your tools here. If you don't remember where anything is, you can always just search for it up top here. I think that is a really
materials.
Cool feature. No, I wouldn't go. If I was doing a body of water like a pool, I would go to volumes, and then I would choose a water volume. But because it's more like a large body here, I would choose. I don't remember what category it's under, so I'm just going to.
I think it in landscape. Wait.
No, not in landscape.
Materials.
It's in materials, sir.
Right in water, sir. It go give you all of the water options. Yeah.
Right, but what I'm looking for is not these, but the ocean. I don't want to change the material, or I want to
Oh, you want to add water?
there is an infinity water that you can add, which is under, is it under miscellaneous?
I was wondering if Twinmotion kind of limited to certain things. Cause even landscape right there. Why they would have a water feature, or is that something you
No,
have to
well, you
add
can modify
to
the
it?
landscape to what you want.
Maybe liquid, sir. Maybe right in ocean or liquid or.
Sir, the water thing was defined because the other day.
It's here, man. It's under one of these. Yeah, what you were saying? I just forget which category it's under. But there is
Sir,
ocean.
try weather. I think it's under weather. You can go to weather.
Under weather.
Under weather.
You press on and off for sea for water, I think.
Ratted, yes. Yes, for real.
Under weather.
What is weather under?
You can turn on. Turn on ocean. Go.
I think it is in the.
It's down there, sir.
So
we
that
have to
water,
import and
no,
export.
that's the same water materials.
No, not in that.
Where is
right
it?
on. Carry down the cursor all the way down to where the export and media and all of those is.
Oh.
Click on the leaf. To oceans there.
Ah, this is where you
So
are.
enable
it, right. And then you set the height. Right. That's what I was looking for. So it's not an object, it's like a scene element that you add.
Yeah.
I never saw that one. Cool.
Yeah, is it? Maybe use it the other night.
So it adds globally to the whole.
For this dance. This first.
Yeah, and it can raise it.
Right.
So it is like it finds the dips and it just like.
It just
oh,
fill
you
it up.
created the
like
dip.
a flat surface.
You created dip, you know.
Right. Right. So there we go. I like how it does.
Yeah, I like that. That remember.
I prefer this than
than
when they come up.
Remember that Far Cry.
It really does make it look better.
All right. So the next.
What it does is basically a horizontal bath of water throughout the whole scene.
Right.
Yeah.
So your heights and the levels is how it's gonna end up to be.
Okay.
Interesting.
Right. So you can, if you want to add some rocks. Oh, oops. Rocks, then you can add some rocks. What I like about Twinmotion is, well, both of them actually. You can import your own objects, but of course, when you use the Twinmotion objects, they just work out a bit easier. Because they are made for Twinmotion.
Even with that body of water, you know, you can actually import a video or a GIF, I would say.
All right.
Of a water body and replace all of that. Yo, it's sick.
Yeah, you can. But both, whatever one has, the other one has a counter. So the real thing is that you just, as I said, look on the wider picture when you're choosing one, because one will get a new feature today, and tomorrow the other one will get a new one. So look on the wider cost, like.
Leaf down below on the left hand side. I'm not seeing that on my screen.
Say again?
How do you get the leaf to get the water, to go to the water? The leaf button.
Oh.
Click it,
Right.
click on oceans and then enable it.
And you go to enable. Right, then you can choose the type of water.
Yeah.
It's tropical.
Okay, it's tropical, sir. Yeah.
Oh, green water.
Okay, so the next thing is, of course, if you wanted to add people and those things, you'd go here, trees. So let's say you want to add some additional trees here.
Oh, I don't see animation to make people swim. I don't know. I just wanted to do that. I don't know.
Oh, you're not seeing that. Ah.
Yeah, for
maybe
characters. Humans.
I see like chilling and dancing. And...
Oh,
No,
you don't see swimming.
You can have kids play.
Yeah, I have that. Yeah.
But beside the
But you
water.
see, a lot of these now are based on the versions.
Yeah.
So
I mean, probably not an updated version. They'd add that to it.
right, right. Because you, of course, you have 2020, and this is 2019. But anyway, I'm just kind of focusing on what you need for the assignment. So apart from this, you need to do a 360, I believe, of the building.
Oh, like a video?
Yeah, man. Okay, let's take a look just to make sure we're on the right page.
Mhm.
Sometimes we kind of get lost in this and we don't look on the actual handout.
Could you go through how
Kind of
structure
food business. Kind of food.
How to
You
what?
think you need 4 things for checkpoint 4?
Yeah, one of them is the exploded view. So we looked on that last week. The other one is what? Is a render. I think it's 2 renders. Let's look on the handout.
You have the render, you have the section, you have the exploded, and you have the perspective.
So you sent the link for last week class, sir? There's the link.
For last week, I'm going to check on it in a little bit. Right, so here we go. Right. Right, so for checkpoint 4, you need 1 post perspective, 1 exploded, an orthographic, this is perhaps the easiest one, and a 3D section, right? Then now you need a 360 animation here. Okay?
Yes, sir.
So for this checkpoint, you're actually supposed to submit
4 things.
Yeah, animation files, not exceeding 300 megabytes. Okay. All right. Now to do an animation in Twinmotion, so I'm going to skip this stuff. You're going to go down to your output section here. That is here. And of course, images. Let's go to images first. So if you go to image, you can go to create image. Now this is the part that might get a little confusing. Now, right now you're in media mode, and while you're in media mode, you're actually determining the view that you want for your image. So, for example, if I click on this now, it's going to go back to this view because this is the view that I was in when I went into media mode. So for example, if I wanted a shot like this, I would now have to click the update button. You have to remember this right here. And then it would update it to this. So if I exit media mode, I can move around and it's not affecting the camera because I already set a camera with this view. Once I click this, it's just going to jump back to that mode. So I can name the image. Oops. I can go here to set the time of day. Remember, this is only being done for this image only. I can go to more and I can do things like set camera settings, frame of view. So, you know,
I think one thing I was looking out for the whole media section is if you can change the resolution or the output. So if you can make it look more like a realistic image, or you can make it look cartoony. I wasn't really seeing that for Twinmotion, but they can do it for Lumia.
Yeah, you have themes. Like you
They
have
look at themes, yeah.
Yeah, I noticed that. As I said, they are going to trade blows. They are going to trade blows. Because imagine, I don't think that's a decision where you choose. For example, if you're opening a firm and you're trying to pick, you can't decide on that little decision. You have to decide it on a much bigger thing. Because next year it might have that. You know what I mean?
True.
Yeah. But anyway, so you can go here to change your output size. right? So you can make it bigger or 4K, or you can go to more and choose a custom size. So let's say you want to make it widescreen, so maybe 2500 by that. And you see, notice that it's wider now, so you can have like a custom mode there. All right, let me go back to more. You can also change the lighting. So this is interesting. You can change like the brightness of the sun and all of this stuff. This one is good where you can change your shadow kind of quality. The closer you are is the closer you want to set this. But when you do that, you buy deep. So let me show you what I mean. If I make it so close, you can actually, let me zoom out. Oops. I keep going down because Unreal controls different than this. All right, notice that when it's all the way down to 50 meters, you don't get any shadow. And notice as I go in, you start to see shadows come on. So the trick is that the more detailed the shadow is, the smaller the area. So if you look at this shadow, it's way more detailed. But then if I go too far, it disappears. So for close-up shots, you want to have that detail high, but for far shots, you want to have it low. You want to have this low. All right, so you can choose that. So I can just go back here, and click back on this image to go back to where I was. Go back to more. Depth of field does what it says. Depth of field is, you know, the background is blurry. You can adjust that distance, which is good. So for example, you can have, let me use the, oh, this doesn't have the feature. 2020 have the feature where you can just click and that area will become in focus. But this one, you have to kind of gauge it. So if you notice, this section here is sharp. You see that? But the foreground is blurry and the background is blurry. So you have to kind of move this distance to where you see fit. And then you can even choose the far blur and near blur. So I can have things that are further away, more blurry or less blurry. See that? And nice little feature. All right. And I mean, the rest of this speaks for itself. You can rotate the background. As a matter of fact, you might want to change that background. So let me go and do that. To change the background, you want to go to here, and context, and background. Okay. Oh, I need to come out of media mode, right? And maybe I want to go with just a blank kind of landscape like country. Then if you want more clouds, then you need to go into weather and change the weather. With a little bit more clouds, there you go. And you have rain and all kind of stuff. You have seasons. This was what made Twinmotion had the edge on Lumion first, because it had seasons. But then Lumion got that too, so I mean.
And perfected too.
Well, he who does the race last always perfects it. So I mean, you know, when I'm sure whenever Twinmotion 2021 comes out, then they're going to have like, I don't know, maybe space or something. All right, so you have those. By the way, when you save an image, it actually does further enhancement on what you're seeing here. So you might notice it looks a little better. All right, good. So to save out your image, you just need to go now to output, and then you can output your image here. Where go again? Choose here, perspective view. Here. All right, I don't want to edit any of these. That's okay. Where's my image not coming up? It should come up. All right. Oh, I need to be in media mode. No.
You need to hit the checkbox, sir. Oh yeah.
I don't remember everything. All right, you're right.
You just did it.
Right.
Yeah.
And then I export this shot and it will ask me to save it. And
it save as a JPEG?
Well, depends on what you choose. I think the default is a PNG. Is it? I would want it to go to a PNG. Is it here that?
Oh, is that
no,
it's when that JPEG it save it as.
Okay.
Well, PNG.
Okay, good. PNG is more the standard that you would go by. Once
yeah,
it's a PNG,
you can further render it in Photoshop also.
So if I look here on my desktop, there it is. You notice that looks better?
Mm-hmm.
So that's why I'm saying when you save it out, it kind of does this glamour shot kind of preparation on it.
Mm-hmm.
If you compare that to Twinmotion, you can see that this looks sharper and it just looks more detailed. All right, good. So that takes care of images. Now for animation, what you need to do is, well, how about we save our files just in case, because this will crash. Right?
I'm glad you said that, sir.
Mm-hmm. And the thing is, Twinmotion saves everything in one file. More professional packages, it's not going to do that. It's going to save it as multiple files. All right, so you go over to video and you go to create. And how this works now, it works based on keyframes. So when I go to create clip, what these are different, let's call them clips or scenes. So this first scene is made up of a particular video clip. And then I can have another scene and another scene. So maybe I could have a scene of the exterior, then another scene of the interior, and all of that would make up your entire video collection. For this assignment, you just need one scene. So how this works is, if this is my first shot here, then I just choose this reload button. If I want to create another shot, I put the plus button, and let's say I go over to here like that. Now automatically, if I hit play, oops, I didn't set the next one, my bad. Let me set this one. Let me
You can also have transitions.
Well, transitions would be between video clips.
Each clips. Yeah.
Update that there. Good. So now you notice it just goes between them.
Mm-hmm.
So essentially what you do is you click the plus button to create another clip, or rather, let me undo that. The best way to do it is, this is this one. For the next one, move it first, then click the plus.
And then add it. Mm-hmm.
And you move it again. Let's go up a little bit and look down. Then click the plus. You move it again. Then click the plus. And you can pretty much do that to get done. There we go. And all of that makes up clip one. So I want to call clip one 360 view. Good. So now if we preview clip one, go back to video here.
Click on play, sir.
Yeah, just click on play. Play here.
Mm-hmm.
There we go. If you want to change any of this, then I think if you have a wider screen, it's better. See?
Right, sir.
I can go back to any one of these clips and replace.
Sir,
yeah,
you don't
question?
see a distinct line right there.
Say again?
You don't see like a distinct line right there.
I was going to ask about is it like, it's like a joint that is selected or something.
Oh, yeah. But that doesn't matter.
Yeah.
See, I can select any other object here.
Mm-hmm.
So it doesn't matter.
Just click escape twice and
Or
select.
press escape, yeah. Whatever it is. But that's not it rendered, you know. When it is rendered, it's going to look better than what you see here, you know. So
Yes,
what I need to do is quick media mode. Then I go to my export. And this time I have video, so I'm gonna stick to render this, which is, remember I named that clip 360 clip. You only need to do one clip for this assignment. I can go to more and change additional stuff. See the format here? So I can make the format in one of these, but that's okay. I'm gonna leave that and just go to the export. And I'm gonna save. And now it's gonna render. And remember when we spoke about the video card now? So if you look here, you might see this slowing up a bit, but you can pretty much see the GPU, this is my GPU here. You can pretty much see that that is being fully utilized. So much so that my computer is barely moving. I actually have this new program here that I use to monitor my system down here. So this is the GPU and GPU memory. You can see that's being used fully there now. GPU usage at 60%. And this is my GPU temperature. Okay.
So the only thing you change out if you're planning on upgrading is your CPU.
Well, this is a laptop I'm using, so you know, no luck there.
Yeah.
That's the thing with laptop. You kind of cache in all your chips one time. All right, good. Now it's rendered. So if I look on my desktop, I should have that video there. Here it is. And pretty much that's what you need to submit. So this would be one of your submissions, and this image would be one of your submissions, and the other two submissions you would get from Revit, from the Revit program itself.
Remember, you can also adjust the time in the video, sir. So I think
when you say time, you mean what? To slow it down?
Yeah, I think yours was 10 seconds.
Ah, okay, yes. All right, so of course there's tons more that you can do in Twinmotion, but where I would leave you is I normally like to kind of explain a little bit about, you know what I'm saying about something like too good to be true. Ever heard that term before? If something is too good to be true, it probably is. Ever heard that term before? So where I will leave you is a kind of a broad brush of the visualization industry. Oh. Remember to mute your mic if you're not using.
Come on.
Okay, so so that was a quick preview of using Twinmotion to get out the two deliverables that you need. Where I want to leave you is for those of you who are thinking about visualization on a whole, and you might be saying, but you have programs like Twinmotion and Lumion. So why would you even use like more complex programs like Unreal or 3ds Max or Maya or those things? You follow me?
Yes, sir.
You guys following?
Yeah.
And I get this question all the time, so I want to just give you my best analogy on this question. A good way that I normally explain this is I have found a good analogy to be in the medical field, right? I have a lot of family members that are nurses, not doctors but nurses. And you know, some people might come from a family that are doctors and so forth, and some and you know and so forth. But what I've learned from the nursing industry has actually helped me to explain to persons a bit more, because one would say you might have a 3D artist out there that posts an image and they say, wow, that looks good. And then you might have another, let's call it 3D artist, that posts an image, and that image was done in Twinmotion. And you say, wow, that looks good. But then the knowledge of the 3D artist is like 10 times the amount of the knowledge of the person that uses Twinmotion. And you might be saying, but you know, why would I go to school to study for 4 years to learn about visualization and Twinmotion? I mean, I just learned it in one class. I mean, what else could there be more to learn? Because look at this, the image that we produced in class. It was pretty good. And it, you know, you can use that to sell a project. Am I right?
That's right.
So you might be saying, you know, why would I need to study visualization if you wanted to focus on that? Because there are companies out there that do visualization, and it's people that, you know, they do like masters in visualization and all of that. But to how Twinmotion is easy, you don't need a master's to use Twinmotion. I mean, my 8-year-old son could probably use Twinmotion, and he would probably think it's a game. But anyway, so just to point out, what happens is that how long does it take you to study to be a doctor? Anybody?
7 years.
7 years. So the doctor, I can't, it's hard to write on the screen. But anyway, so the doctor takes 7 years to be a doctor there. Hold on. I think one would argue is more than 7 because you have to intern, or that includes intern. I don't even know. How long does it take you to become a nurse? Anybody?
4 or 5.
4 or 5. Or 3. I think
of course, sir. Me get real confirmation just now.
You get real confirmation?
Yeah.
Okay, so it takes 2 years.
This one, yeah. That's not which.
Right, because I've heard places that say, you know, 3 years and so forth. You know, but you know, funny enough, I never hear of like a 5-year doctor place. But anyway, so this thing not touching. Right. So let's say it takes 3. Sorry, not 3, but 4. 4 years here. It's there. So starting from scratch, it takes me 7 years to get to the doctor. It takes me 4 years to become a nurse. But you know, I know about this because there are some nurses, if you want to go higher than a nurse, you can go to a nurse practitioner. And I don't remember how long does that take. Anybody have that idea? I think it takes like a year or 2. But anyway, so let's say that it takes maybe 2
About 6 to 8 years.
Additional?
No. Say 2 to 3 additional.
Right. Okay. So let's put it at 3. Right. 3. So the funny thing is, when you add all of this up, you get 7 years here. And you also get 7 years here. But, sorry, let me write this. So this is the nurse. And this is the doctor. Right? Even though it adds up to the same amount of years, the nurse still cannot do all what the doctor does. You get what I'm saying? The amount of knowledge that the nurse has is still not the amount of knowledge that the doctor has, even though they spent the same amount of years in school. I know you're the messed up thing because I've asked her if a nurse wanted to change career and become a doctor. Well, one would think that, oh, well, you know, maybe they would start somewhere in the middle, you know, it would knock off a couple of years, but no, they have to go back to the bottom and do 7 years again.
Yeah, because it's not the same thing they learn.
Exactly. But the funny thing is that when you go to the hospital or you go to the clinic, you know, they almost do the same thing. I mean, there are some clinics there where they don't have a doctor, but they have a nurse practitioner. And the nurse practitioner write prescription and everything, but they're not a doctor. But they have spent 7 years. You follow me? But if that nurse practitioner wanted to become a doctor, they would have to go back to school for 7 years. So, but in your eyes, what you are getting from these two people are almost the same. Granted, if you go into a surgery, it's different. You won't have the nurse. But what you see in a clinic, you see the nurse practitioner writing prescriptions, diagnosing you. You see the doctor writing prescriptions, diagnosing you. Generally, they look like the same thing. And this is a similar thing to visualization. For persons who learn Twinmotion, for example, or Lumion. Let's say you do this class and you learn Lumion, fine. But let's say you really dive into it. So you probably spend, maybe if using Twinmotion for 3 years. So you've like reached the pinnacle of Twinmotion, like you know how to do everything. Twinmotion has a ceiling. Lumion has a ceiling, meaning, you know, you can't make like a, I don't know, a X-Men spaceship to animate in Lumion or Twinmotion. But maybe you don't need to. You follow me? But the thing is, if you're going to invest all of this time, and this is where you have to choose, right? If you're going to invest 7 years, is it better to invest it to become a nurse practitioner or invest it to become the doctor? If you're going to spend 7 years. You get me?
I get this, sir.
There are some cases where you might not need more than what the nurse practitioner gives you. Fine. So you work in an architectural firm. Your objective is not visualization. It is, you know, architecture, you know, approvals, designs, the administration of architecture, that kind of thing. Then, yeah, you don't need to study to be a doctor, so to speak. You know, the nurse is good enough. But then for those of you who might want to go into some kind of visualization, but you look at Twinmotion and Lumion and say, oh, but this is easy. Why would I choose to go through and learn the complex 3D Max and all of this doctor stuff? You get me? When I can just learn the nurse stuff. You get what I'm saying? But what happens is that people reach that ceiling. So I have some persons who come to me and they say they want to do more things in visualization. And I say, what program you use? And I say, well, I use Lumion. And I say, well, you have to go back to school for 7 years. Because you cannot add on top of what you learn in Twinmotion and Lumion to do what that video that I showed you of that walkthrough. Remember that I showed you at first? What you learn in Twinmotion and Lumion will not help you. It might help you in like 1%, but it basically will not help you to do that level of work better. So I always point this out so that you can choose from the beginning. If you think that you want to specialize in some form of visualization, nowadays you have all kind of people who do augmented reality and virtual reality and that kind of stuff. If you think you want to specialize, don't invest the 7 years in Twinmotion and Lumion, because you will have to start again if you want to go higher in visualization. Everybody understand that analogy?
Yes, sir.
Okay, good. So that is where I leave you. I hope this has been informative. I will check on this video. Let me stop the recording now.
Mr. Williams.
Yes.
When you going through that little part about how you invest your time and energy. I thought you were going to be even more facetious and talk about studying architectures against studying visualization.
Well, nowadays you can study something and specialize in almost anything.
Okay.
You know, who knows?
All right. Anyway, I want to thank you very much for the time that you have spent with the class today. Much appreciated.
Okay, no problem.
I wish one of them would have said it, but let me thank you on their behalf. Please say it, Mr. Williams. Please say it.
Thank you, sir, for the information that you just provided. It was really helpful.
On behalf of the class.
On behalf of the class, yes.
Yes. We really appreciate it, sir.
Okay, that's good. That's good.
I hope we learned something.
Yes, I hope so too.
We'll definitely be seen in the next checkpoint.
That's
or
true.
even better.
Sir, you should have really done Lumion still because
no, brother. Everybody I use Twinmotion. We can't afford Lumion.
I know Twinmotion, that's why. I don't use Lumion, that's why.
But sir, can I ask a question, sir? Like, what programs do you currently use now? Like, I know it's like beyond or realm on the
No, it's not beyond nothing, man.
Oh.
You just need to start. You just need to start it.
I guess it depends on what you're doing also.
Exactly. So that
students. Sorry, Mr. Williams, please continue.
No, okay, I was saying
I
that.
wanted to say to my students that they need to let you go.
Right.
Sir, we can get the recording.
Yes, I'm actually checking on that now. The last, but yes, you get the recordings. My internet here isn't as fast, so you probably like midnight tonight, thereabout, because this is going to be about a gig or so.
Okay, sir, that's okay.
Right. But remember what I said, don't choose the program based on those little teeny features like this one have, you know, females in skirts and this one have females in bathing suits. You know, there's no, you know, or this one has an airplane and this one has a animal. Choose it based on broader factors like, you know, what's the company that owns it and what's the longevity of the program? What's the cost of it? If you have to buy a license, you know, how much it's going to be. Things like that. Because they will always trade blows. They will always trade blows. All right. And if it is that you want to go into visualization, then you know that you will have to invest into other programs that is more that has a higher ceiling. Because as I said, when you hit the ceiling for these easy programs, you can't just transfer. You have to start from the bottom again and come up. So also think about that as you go forward. Okay. Remember where you go to find the videos, guys. You go on the website. I'm just do a quick demonstration so you find it. Where is it? Oh, share screen. Share screen here, right? Right. So remember that you go to the website and then you go over to forums. That's right here. You go to forums, and then what you would do, you would look for your subject area, which it's not there yet. I'm going to put it there. So you look for 3D modeling, and then you will see Zoom recordings. And then when you go in there, you will see, oh, you have to sign in. So make sure you sign in. You can sign in with your Google email. Doesn't matter. So I'm going to log in here. I will use login with Google, and I will use my Google. There we go. And once I'm in, let's go back here.
And those would be the recordings since the beginning of the semester?
No, only mine.
Oh, okay.
Once you go there, you will see those recordings. It is on YouTube, but it is not public. So you can only watch it from the link. So if you go on YouTube and search Zoom recordings, you won't find it. All right. So that is where you go to access the recordings after, let me say, sometime between tonight and tomorrow. I will leave it uploaded and go to bed. All right.
All right, Mr. Williams, thank you. Thank you, students, for your attention. Very good.
Thanks,
We had a
Mr.
good class. Excellent class. Okay.
All right, guys, take it easy.
All right, sir. Bye.
Mhm.